We're going to be discussing molarity and dilution. So just to review, molarity. Molarity is the way that we measure the concentration of a solution. There are other ways to measure the concentration of a solution, but molarity is going to be the way that we measure the concentration of a solution in chemistry most often. Molarity is calculated by taking the moles of solute that's dissolved in the solution and dividing it by the volume of the solution in liters. When the molarity is high, we describe that as a concentrated solution. So anytime there's a lot of solute dissolved in it, then that is a concentrated solution. So then what's dilution? Well, another way to describe dilution is watering down a solution. In a dilution, what happens is the concentration of the solution is decreased because we're adding more solvent to the solution. And a lot of times we use aqueous solutions where the solvent is water. So watering down a solution really is a good way to describe dilution. We're adding more of that solvent, usually water, to the solution, which makes it less concentrated. So again, remember that the way to calculate molarity is to take moles of solute and divide it by liters of solution. And mathematically, if we are increasing the liters of solution, we're increasing the bottom of that proportion. And anytime you increase the bottom of a proportion, you actually decrease the value of that proportion. So by increasing liters, we are decreasing molarity. So the thing is, we're not changing the amount of solute. So the number of moles that's dissolved within that solution stays the same. So if I have 1 mole of salt dissolved in my solution and I add more water, I still have just 1 mole of salt dissolved in that solution. It's just less concentrated now. And the way that we calculate moles is, if you look at that triangle, moles is the product of the molarity of the solution times the volume in liters. So really, if moles is going to stay the same for both my concentrated solution and my diluted solution, what that means is the product of molarity times liters for my concentrated solution and my diluted solution is going to be the same. And again, a concentrated solution is one that has a high molarity. Oftentimes, stock solutions or solutions that are sold by chemical supply companies have a high concentration. The reason that stock solutions are concentrated solutions is that companies can ship you a concentrated solution and you can then take it and dilute it to make a lot of diluted solution. So it's more cost effective for companies to sell concentrated stock solutions rather than selling diluted solutions that have a lot of water in them, because you can always add your own water. So that's why a concentrated solution is often known as a stock solution. So if we are changing the volume and changing the molarity, how do we calculate that new molarity of a diluted solution? So again, if I know that the product of the molarity times the volume is the same for both my concentrated solution and my diluted solution, I can set those two things equal to each other. So in this equation, M1 represents the initial molarity, or the molarity of my concentrated or stock solution. V1 represents the initial volume. So that's the volume of that concentrated or stock solution. M2 represents the molarity of the diluted solution, and V2 represents the total volume after the extra solvent has been added. So V2 represents the concentration of that diluted solution, the total volume after the excess solvent has been added. So here's a good example problem for us to start with. How many milliliters of 1 molar sodium hydroxide are required to make 100 milliliters of 0.27 molar sodium hydroxide solution? Okay, so the first thing we need to do really is read and use context clues and figure out what we have. Remember that we have really 2 solutions we're dealing with. We have the concentrated solution and we have the diluted solution. Each of those is going to have a molarity and a volume. So I know that they described part of the solution as being 1 molar, and then they asked us the volume of it. So we do not have the volume of this 1 molar solution. They also described for us 100 milliliters of a 0.27 molar solution. So I have both the volume and the concentration of that part of the solution. We need to figure out what each of those values is going to represent in the equation. Which set of values represents the concentrated or stock solution, and which set of values represents the diluted solution. So there's a way that you guys can identify it pretty easily. We know that we're diluting it, which means we're decreasing the molarity. So the higher molarity should be your concentrated molarity. That's going to be M1. And the smaller volume is going to be V1 because remember we add solvent to the solution to get V2. So V1 is going to be the smaller volume and M1 is going to be the higher molarity. So then if I look at those values, 1 molar was the higher molarity, so that's going to be my initial molarity. And the unknown volume that went with that value is going to be V1. M2, that new molarity that was created after dilution, was 0.27 molar, and the volume after dilution was 100 milliliters. Now we can go ahead and use milliliters in this problem as long as we understand that both volumes have to be in the same unit. So if V2 is going to be in milliliters, then V1 is going to end up being in milliliters. You could use liters as well. You just have to make sure that both V1 and V2 are in liters. So you can use either milliliters or liters to do these dilution problems. Just make sure that V1 and V2 are the same unit, whichever one you choose. So then the next thing we have to do is once we understand what each number represents in the equation, we have to go ahead and substitute those values into the dilution equation. So remember it's M1 times V1 equals M2 times V2. If I go ahead and substitute those values in there, I get 1 times x is equal to 0.27 times 100. Then we have to do the math. So always remember the order of operations. Once I have those values substituted into the equation, the first thing I have to do is the multiplication part of this. So if I multiply out both sides of the equation, I end up with 1.0 times x is equal to 27. To solve for x, I need to divide both sides of the equation by 1. That's going to get this to cancel out, and I can see that x is going to be equal to 27. Since x represents V1, the initial volume of that concentrated solution, V1 is equal to 27 milliliters. And again, that answer is going to be in milliliters because V2 was in milliliters, and so those units are going to match. Okay, so the next example. This one's a little bit tougher. So a stock solution is made by dissolving 10 grams of sodium chloride in 500 milliliters of solution. The solution is then diluted to a final volume of 2 liters. What's the concentration of the final solution? Again, we need to read through that problem carefully and figure out what we have. Remember that they're describing the solution, it's almost like two solutions, right? They're describing the concentrated solution and the diluted solution, each with its own molarity and volume. Now the first thing they told me is that I had 10 grams of sodium chloride dissolved in 500 milliliters. So that's how they were initially describing the solution. Then they said later on it had a new molarity. We don't know what that is, so it's going to be X. And the final volume was 2 liters, so that's the new volume. Now, looking at those values, we actually don't have an initial molarity. What we have is an initial mass and volume. So we really do have to get molarity before we can use the M1 V1 equals M2 V2 equation. We can look at the molarity triangle and use that to help us calculate molarity for this problem. So first, we know that we have 10 grams of sodium chloride, but our amount of solute always has to be in moles. So we're going to convert that to moles. So if I use the molar mass of sodium chloride, what we end up with is 10 grams equal to 0.171 moles of sodium chloride. The next thing, when we're doing molarity, it always has to be in units of liters. So we're going to convert the 500 milliliters that was given to us into liters, and that turns out to be 0.500 liters. Now if I think about it, we're calculating molarity here. So if I cover that up in the triangle, what's left is moles over liters. So the amount of moles that I have calculated needs to be divided by the number of liters that I've calculated. So the 0.171 moles is divided by 0.500 liters, and I end up with a molarity of 0.342 molar sodium chloride. We need to think about what all these numbers are going to represent in the dilution equation, which ones are representing the concentrated solution and which values represent the diluted solution. So M1 is going to be that 0.342. V1 is the 500 milliliters, or we went ahead and converted that to 0.500 liters. We don't know the new molarity, but we do know that the final volume was 2 liters, which is greater than the 0.500 liters that we started with. So that has to be the value for V2. And if I look at my units for volume, I know that I was initially given 500 milliliters for the V1, and then I was given a volume of 2 liters for V2. We have to use the same unit for V1 and V2. So I'm going to end up using the converted value, the 0.500 liters, for V1 whenever I substitute these values into the equation. And that's the next step. So you go ahead and take those values and substitute them into the equation where they belong. And so I have that initial molarity of 0.342 times the initial volume, 0.500, set equal to my unknown molarity times the 2.0 liters. When we start doing the math, again, we multiply first and then divide. So if I multiply out both sides of the equation, I end up with 0.171 equal to 2.0x. To solve for x, we need to divide both sides of the equation by 2.0. That way the 2 here cancels out and I'm left with x. So x is going to be equal to that new molarity, the molarity of my diluted solution, which is 0.0855 in the calculator. However, if I look at all the values that were given to me in the problem, the value 2.0 liters only contains 2 significant figures. So I'm going to round this answer to contain 2 significant figures. So my calculated answer of 0.0855 is going to be rounded to 0.086 molar. So the concentration of my diluted solution is 0.086 molar sodium chloride. We can actually think about our answer and see if that makes sense. We started with an initial molarity of 0.342, then we added water to dilute this solution. So our molarity should have decreased from M1 to M2. If I look at M2, it is less than M1. So I started off with 0.342 molar, I ended up with 0.086 molar. So that answer makes sense because my diluted molarity is less than my concentrated molarity. So that's just another way that you guys can check your work. I hope that this helps you guys with your dilution problems. Make sure to reach out if you guys have any questions. Good luck!